All right. You hear me now, huh? Brilliant. Awesome. Thanks for coming. I know there's like tough competition with so many great talks in parallel, so I really appreciate the time you've given me. Hopefully, I'm not gonna disappoint you. If I do, you. What's that? No. If I do, just let me know. I'll give you free AWS credits. You have to trade for everything. Today we're going to talk a little bit about chaos engineering. Before I'm starting the talk, how many of you practice chaos engineering? And I'm not talking chaos, because that's pretty much everyone. But how many of you practice chaos engineering? That's a very good question. Yeah, on purpose, right? Not as a consequences. All right, so pretty much no one. I saw half a hand, like, so someone was kind of shy to say that. But yeah, we all practice chaos, that's for sure. But chaos engineering is something a little bit different. It's really trying to break things on purpose to make things more resilient. I'm Adrian Hornsby. I'm part of the technical evangelist team for AWS. I've been actually lucky enough to have been working with AWS technology for about 12 years. First as a user and customer, and a lot of that talk, a lot of this kind of things I want to talk of result from all the failures that I've had, all the mistakes I've done. So usually that's how you can share knowledge. You never share good stuff. You always share bad things. I guess that's the natural things. So that presentation is actually a kind of a baby of that. So hopefully you can get some goods and bads out of that. First, we want to start with this. How many of you are firefighters in the room? There's one. That's brilliant. So there's something really peculiar with firefighters. First, they are like heroes. They're great, amazing, but they do insane amount of training. Actually, before going on the spot and starting firefighting, there's about 600 hours training just before doing the first job. And then after that, they almost spend 80% of their time training fighting fires. And you know why they do that? You're not allowed to answer. It's very simple. They want to build intuition into being able to fight fire, because when they go on the spot, there's no time to think, right? They have to know exactly what's going to happen. You think, you basically can't, really do it fast enough, and basically you're out. So they want to build this intuition about how to behave with fire. And I like to think chaos engineering is very similar. And actually this idea of fighting fire is kind of long, quite an old idea. In the mid-2000s, actually in the early 2000s, Amazon.com went through a massive growth. Actually, we were first a big monolith application. We split that into microservices. And our user base grew and grew and grew, and we started to have outages, right? Because our blast radius started to increase, and it was very natural for the platform to experience big outages. So we hired a guy called Jesse Robbins. Jesse Robbins was the first amazing software engineer, but he was a firefighter. And he brought that idea of training for fire to Amazon. Basically, what he wanted to do is called game days. He brought something called game days. We still call those games days today. And the game days, basically, he was going around the data center and unplugging things, literally in production. Unplugging power units, cables, cutting cables inside the data center, and simply to test resilience of the services and the platform, but also to give practice for the new engineers into how to deal with outage. Right? And to do this in a kind of semi-controlled environment. It went up till that they actually closed the whole data center to test in production. The result was kind of a bit bigger than expected, so they stopped doing that. But they learned a lot. And basically, we still do chaos today. Every time we launch a new AWS regions, we do chaos for a few weeks before the service are open to customers, where we try breaking things on purpose. We didn't call that chaos back then. We really called that game days, right? And basically was stuff we did. What was very, very necessary for us is basically these microservices, and this is kind of the dependency map of microservices at Amazon. You see a strong dependence on the bottom. It's actually the retail web page. But any architect can't make sense of any of that. It used to be quite normal where you have maybe 4 or 5 services working together where you could kind of make sense of what was interacting with one another. Now in the distributed systems like that, it's impossible to figure out what's happening. It's actually impossible also to have all of that working and being operational 100% all the time. Statistically, at any given time, there's always something failing, right? And this is kind of reflected in the way we build things, actually. And you will hear Werner Vogel, CTO of Amazon, saying all the time that failure is inevitable and will happen. Everything will fail. So basically, that's one of the things we really did a lot, trying to break things and kind of experience with that. But actually, the big turning point for chaos engineering, in my opinion, was Netflix. In the end of 2014, Netflix was already migrated to AWS, and they were in the US East region. And the data plane for the load balancer experienced an outage. And Netflix went down for a few hours. And they basically started to think about how to build cloud-native, extremely resilient architectures. And then to help them build that architecture and actually test it, they went into creating tools. The first of those tools was the Chaos Monkey, actually. I'm sure many of you have heard about Chaos Monkeys. The first little guy here in the middle is Chaos Monkey. And this one was a script which was like scheduled to run a few times per day and randomly killed servers in production. And that was done so that actually everything that was deployed was made sure that it could be resilient. And what's the best way to test resiliency? By just unplugging things and breaking it. So that it forced people to actually really think about resiliency as a first class of how you build your application. And then it quickly followed by what they called the Seaman Army, which was a bunch of tools to test a lot of other things within the architecture. And then the big gorilla there is actually a monkey that randomly takes a full region out of Netflix in production. So Netflix runs in 4 different AWS regions, 2 in US, 1 in Europe, and 1 in Asia. And that crazy gorilla literally takes a region out while people watch Netflix in production. Legend says that they do that once a month while people watch in production, while you watch Netflix. And so that's kind of the holy grail, I would say, of chaos engineering. And that's actually also a problem because a lot of people heard about Netflix and the way they do chaos engineering and started to think that, hey, chaos engineering needs to be in production. And if you say that to your manager, trust me, the first thing is going to say, you are nuts. We're never going to do that. We're never going to break things in production. But if you call that safety engineering or resiliency engineering, all of a sudden you have someone to talk to. So it's very fun on CV, and it's very fun to talk about chaos engineering, but if you want to talk inside your company, never ever mention the word chaos, talk about resilience. That's going to be my first advice for today. When you do resiliency engineering or chaos engineering, there's a whole cycle of things to do, but actually the centerpiece of it is fault injection. So what we will do is we create an experiment, and I'll talk a little bit about that later, and then we inject failure. And of course, failure has to go through the entire stack. When I meet customers and I set up chaos engineering practices, the first thing I do is actually not an application infrastructure attack, is a people attack. And that doesn't mean I break necks to people in production. I never killed anyone while doing chaos engineering, but what I do, I identify team leaders or people in teams that actually are the exceptional type of people. I had 2 in my life. Twice they were called Paul, so I usually call that the Paul attack. Those guys, you give them anything, they fix it while looking at you, making a joke, drinking coffee, and you never really know what happens. We all have that guy, right, in our companies. What happens if Paul gets hit by a bus? Well, that's actually the first thing to test, actually. So that's why people are. and I don't hit them by a bus with a bus. I go there and I take the laptop and I say, hey, Paul, today you can go home. And the last customer, I've done that 3 weeks ago, and 6 hours they were able to live without Paul. And we had to bring back Paul very, very fast. And you can think about very complicated things, but that's the first thing actually that you have to do when you want to build resilience, is actually business resiliency, right? Then you can go down and you can say, okay, is my infrastructure resilient? Is my application resilient? And all that kind of things. And there's a lot of things, and I'm going to show you and demo some of the tools today with you. But remember, people attack, because I think we don't talk about that enough. And don't quote me that I say you should hit Paul with a bus. Thank you. So why do we do that? As I said, we want to avoid things to break in production. And we actually, through chaos engineering experiment, we want to break things, not necessarily in production, but we want to break things first to understand if they're resilient. But we want to break things when everyone is in the company. How many of you have stayed out night or Christmas or holidays fixing things because you were on pager and you had to just go there? And it's never during the day, right? It's always in the evening, at night, a wedding. I had 2 Christmas, things like this. Because that's when outages happen. So instead of waiting for that, we actually create a semi-outage through an experiment when all the engineers are in the room and everyone is wide awake. Usually that's 10 in the morning, right? If you do that in the afternoon, usually people are waiting to go home, or then they're like eating. 10 is the optimal time I found that is great. If you start at 9, it's like, no, I need coffee. They make mistake. Really, 10 is brilliant. So that's one thing to do. What it's not, it's just randomly break things. I think that's a very bad image that chaos engineering has. Is the word chaos first is terrible. Makes people think that we just don't control anything. But actually, it's really control, and I'll explain how we do things. And we really break with a purpose, is to validate an hypothesis. Is this part of the architecture resilient or not? And then we go and verify it. So what are the prerequisites for chaos engineering? And should you just start tomorrow, go and say, hey, Adrian talked about breaking things on purpose, so let's take the database down? Well, obviously, no. There's tons of stuff, and that's called the whole resiliency stack. And you have to go and make sure I've done already a lot of work into your application. Is your application resilient? I think the most funny outages I've seen is certificate being expired. How many of you have seen these ones? Right, and it's stupid, right? So how can we avoid that? Make sure that you don't do this. Make sure you have redundancy, right, in your application. If you know the mathematics behind the systems in parallel, if you have a system, a part of a component that is 99% available, that's 3 days and 16 hours of downtime a year. If you put it in parallel, we don't do anything else on the system. You just put it in parallel, you jump to 4 nines of availability. That's 52 minutes. If you do that 3 times, it's 6 nines of availability, 52 seconds, a year of downtime. So that's simple math, and I think a lot of you already probably do that, scale horizontally kind of things, or have duplications of component. And of course, monitoring. I think if you're gonna inject failure, but you don't monitor, well, good luck. And things like this. And also have an alert system that actually works. A very interesting chaos engineering experiment that I've had done actually showed that the alerting system failed, and then we didn't get the alarms on time. So that's also something you have to be sure, right, and think about. And of course, on the application level, there's tons of stuff. How many of you are listing all the timeouts of all the dependencies you have in your systems, like the default timeouts? Do you have a sheet of all the dependencies in your system? So the default timeout for the driver calling the database is actually 15 seconds. Oh, that's something you probably should. Actually, most of the systems have default timeouts, which either are infinite, or 30 minutes, 100 minutes, and things like this. 100 seconds as well for core, for .NET Core, the HTTP request library. So it's like, in the distributed systems or in the system in general, you don't want to have those. So the first thing first is look at all your timeouts and make sure that they actually make sense. Then you have retries and things like this. I don't want to talk too much about that. I've written a bunch of blog posts. I'm happy to talk about this. But today I want to make sure that before going to chaos engineering, there are some work that you have to do. Of course, you can do chaos engineering then in a test environment and in your laptop to help you build these ones, right? And that's definitely something you should do. So the phase of chaos engineering are the following. It starts with, on the up right, a steady state. Eventually, your application is deployed in production or somewhere, and you have a steady state. A steady state is a kind of a figure of, is my application in normal operation? Something like this, right? And usually people use CPU and memory. I always say that's definitely not enough. I'll give you an example. At Amazon, at the scale of Amazon, a CPU or a memory has absolutely no meaning. What we use is the orders, the number of orders per minute, and we can have very, very accurate predictions of those. Netflix used the pulse of Netflix, which is the number of time people around the globe click on play button. And that's a very, very good metrics because it's a direct correlation between user experience, clicking a lot is not fun, and then a service being operational, being able to deliver on that play. So they're able to detect regional faults simply by understanding the number of time people click on the play button. So there's things like this. What is the normal behavior of your system? Usually it's a combination of business and ops metrics, okay? Then you have to go into the hypothesis. And this is the interesting thing is, all right, you bring everyone in the room and you start to ask the question, what if? Actually, this is wrong. It should be what, when, because everything will fail eventually. So what is going to happen when a database is going down? Well, the most important here, and I said that, is to bring everyone in the room. And I'll tell you why. Because when you bring the product manager, the designer, the database, the back end, the front end, everyone in the room will have a different answer to start with. If you ask a UI designer, what happened to my application if I lose the database? I would say 99% of the time I've done that, they have never thought about it first. And they actually didn't necessarily care about this. And for good reasons. Most of the teams actually have separations of concerns, right? So chaos engineering kind of enforce people to actually think in the global view about this kind of stuff. And resiliency starts in the UI. If you have a component, a recommendation engine that fails, well, you just don't want to return to 4.4 and crash the entire application. You just want to degrade or just mask that and say, oh, rebuild your UI so that, hey, have a component that failed, but hey, we can be in a degraded state in kind of a partial error mode type of things. So bring everyone in the room. What I usually do is I ask them to write things on paper. If you ask them to talk, usually everyone eventually ends up saying the same thing simply because they're talking and then bouncing ideas. If you write on papers, you 100% have different answers. And that's actually a moment to stop and say, oh, why do we all have different answers? Then you can go back and, and rebuild your product design and make sure that some of the result from those discussions are actually in the design of the product, right? What is a degraded state for UI? At Prime Video, it's very simple. If we have a database falling down, we go into a read-only mode where we serve stuff from cache. Right? Of course, we lose a lot of customer interaction, a lot of data that could be written, but we say, hey, it's our fault, we lost the database. Our customers should never experience any problem because of our fault. So we fall into a read-only mode and then serve the content anyway. And of course, it's a degraded experience. So very important, do that. You don't always have to start with breaking the database. Actually, always start small. What happens if my load balancer has latency? Latency usually is a deadly sin. It will break stuff. So things I will discuss more about that. Once you have picked up one hypothesis, right? Just say, hey, what happened if my database, my master database, go down, and everyone has kind of the same scenario in its head? Then you go into the running the experiment, and that's where you want to identify kind of what are you going to test. Never ever test on paying customers first. You can always start with customers that are maybe internal or synthetic or things like this. Really, you should protect your customers, of course. So make sure eventually you might do it when you become really good at it. But at the beginning, when you want to start, always starts very small. You say, I'm just going to do a canary deployment on with a new infrastructure and just send 1% of the traffic there and then see if I can run my experiment there. That's usually a good way because then you can have this emergency stop button that is very important. Say, if your experiment starts to go into an outage, then you can stop it and then roll back and move back the traffic to the non-affected environment, which is very important. Always keep in mind the idea of blast radius. Blast radius is the amount of customers, because your customers are basically the goal here. How many customers will be affected, right? This is something super important when you run an experiment. Make sure there's no way to have a cascading failure, which would affect the entire set of customers. And then the emergency stop button is also a fallacy. In some case, chaos engineering experiment will actually write data into a database or will mutate data. And sometimes it's very hard to roll back, right? So figure out maybe before running the experiment if there's a chance that your data might be corrupted, and then have a scenario to recover from that. Of course, these are extreme cases, but it's something you have to think of if your experiment ends up writing something in the database. Once you've done that, most important is actually to verify, right? So you take all the papers that people have written, and then you verify, is that actually what happened? That's why you need to have a lot of measurement about what happened, at what time, and figuring out, yeah, actually, the architect predicted that the failover would take roughly 1 minute and 30 seconds. These are the result of the experiment. We can verify this. If it's not correlating, then you can deep dive on the problem. And why do we have a different understanding? It's, oh, yeah, DNS caching. Oh, I forgot about that. Oh, my TTL is actually 300 seconds, and therefore I can't have 1 minute 30 seconds failover. Happened to an experiment we did with customer, or I did with customer a few weeks ago as well. So these are very interesting to see, right? Figuring out if you can actually prove your hypothesis through the measurement. And this is why it's super, super important to have measures of everything. Once you do that, of course, you have to verify your experimentation, fix your experiment. But before that, actually, something that is super important that I forgot to mention in the previous slide. The most important thing, in my opinion, to detect, to quantify as well when you verify your experiment is the time to detect, right? And this is super important because when you do an experiment, you don't necessarily want everyone to know exactly at what time you're going to run the experiment. So you can test the real reactions of people and the real escalation path. I'd say one of the big outages I've experienced was because our escalation path in the paging system failed. So no one got paged, and we got customers to tell us our system was down. This was pre-AWS, before I joined AWS. And this is a situation where you don't want to know, to be absolutely not. So always make sure that you, through an experiment, you also test the detection time, the alerting system. So it's like a reinsurance that in case of a real problem, actually this will work. Then what we do at AWS a lot is what we call postmortems. We write what we call corrections of errors, where we take a team of engineers to understand what really went wrong, why our experiment failed, or why it was successful. And we use a system called the 5 whys. It's been criticized a lot, but we do many 5 whys, and we ask a lot of other questions. But this is just to start the process of deep diving on the root cause. And we start from the outage. We say, why did we have an outage? Well, because my database ran out of connections. Why did we run out of corrections? Well, because the timeout was infinite, and my client had a timeout of 10 seconds. So every time the client retried, it lost the connection. Why did the retry? I had the different, so you can deep dive and then figure out, yeah, my library, I imported the library, and okay, why did we import the library and not check the timeout? Because we don't have the tools for that. And that's, okay, that's a big problem. Right? So let's build tools to introspect code and figure out all our default timeout and make sure to alert everyone if a timeout is not set. So this is kind of root cause analysis. And of course, from this, I could have given you 5 or 6 different scenarios, and you should definitely do it. The big thing in outages is never one reason. It's always a collection of small reasons, usually happening at the same time, that creates this kind of cascading failures. So make sure that you deep dive into the errors and make sure you actually fix those. And this is very important. Never happens, so that's why I'm saying have different analysis on that. And then comes the improve or the fix, right? And there's no secret sauce here, unfortunately, but I'll tell you that. I had a customer 3 months ago where we did a chaos experiment, and we came out of the experiment with a list of things which were critical and that really, really important to fix. The problem is they continued developing the features, and 2 weeks after, they actually experienced the outage that could have been solved if they would have fixed stuff that we uncovered during the chaos experiment. And this is usually a tension that happens in teams. You uncover problems is, should you stop developing features and then really fix, or should you wait? How do you, I always say fix stuff fast. That customers actually had the 16-hour downtime for something they knew was a problem. So very important, don't let things like this happen. There's plethora of evidence that if you know something will bite you, it will bite you, right? And that's the same with failures. So improve. What we do, Amazon again, once we have a correction of error, we have a list of things to fix. We stop all the roadmap. We actually freeze roadmap. We freeze feature branches, feature development, and we fix stuff. That's our priority number 1. And we don't even have to go to our C-levels. Teams that deploy the service can actually take this responsibility themselves and say, we don't do anything anymore. We just fix the stuff. And this is something that I think is great. It's empowering teams to fix things before problems happen. Now I want to give you some kind of tools and things that are important that you can start playing with in production or in your test environment. And I'm going to demo quite a few of those. So the bananas for monkeys. I always start very simple, start local. I'll give you a story of what I used to do with the team of engineers that I worked with before joining AWS. I was leading a team of about 20 people, and we were hiring very regularly new members. And the first thing we were doing with them on the first week 1 was, write a small tool with 3 different APIs. Write a product, let's say a product API that you can store a product, you can get the product. You have like maybe a synchronous API, an asynchronous API, and things like this. And then we were asking them to make it as resilient as possible, and that's it. And then we were letting the person kind of figure out what it really is. And you'll be very surprised about the results of that and how simple things can actually, like a Docker stop command, can actually help you improve a lot. And I'll show you actually. I still have a lot of the code, and actually I put this code on GitHub, so if you're interested. I call that code Eleanor. I just love the name Eleanor. It's the name I want to call my daughter if I ever have one. So I called my code Eleanor. It's pathetic, but that's the way it is. Sorry. And there's a bunch of different APIs here. There's an echo, a product API, and then you can store things and post. So in action, it looks like this. This is actually, sorry, I'm going to show you the Docker Compose, because that's something I often use to play locally. There's an API front end here. There's a task running Celery, so this is developed in Python. There's a load balancer in front, an Nginx, and then there's a master database, a slave database, and then a couple of Redis containers to do cache, and then also queue. And very often, I would ask then people to make this as resilient as possible, right? And then you can think about, well, the first thing is actually test with Docker stop. I think it's very no-brainer. So, like, if you have, for example, here a health check, you see I have my master database running, I have a slave, I have Redis, it's checked, it's all there. So what I can do is actually a Docker PS and then check for master. I can take, for example, that Docker and say Docker stuff. Oh, maybe I should put the Docker ID. And you see here, this dies gracefully. I always love the die gracefully. Like if ever things can die gracefully. But then just let's test that. You see I have my health check here. It tells me that there's an operational error. So yeah, indeed, my master database is not working, but can I still get, for example, a product? So let's say, can I get a product ID? Yeah, I still. So this is a very good way to say, oh, I can build actually read-only mode. And if you would never break the database, if you would never test locally, actually it's very often you would never think about, hey, my business is not to write to database. If I have data, how can I serve that? How can they do a failover into the slave? Instead, you see here, there was no master detected and force a connection to the slave. And that's the kind of stuff I think that are definitely interesting to do. So the first simple stuff to do chaos experiment is actually Docker Compose and Docker, and then just break your Docker containers and see what happens. Very often it will surprise you. Things never fail gracefully like it was written. But it helps you to figure out, okay, what can I do if I lose a database? What can I do if I lose cache? Is my system able to handle a change of behavior if I lose cache, but I still have database? How do you handle that? And even if some of those are very hard questions, it actually enforce you to think about it. And I think for us, at least in the company, when we set this kind of up, it totally changed the culture of how people design system, because then naturally they were thinking about resiliency every time they built a new component, a new API, and then started to build map of API path and figuring out the critical services and naturally enforce an understanding of what happened if we lose some of those critical services. So something like this, start very simple, definitely is very important. Another very, very nice way to test resiliency is to DDoS yourself. And I'll show you that. Again, I'm gonna use this one. This is actually, so let me see. So here, the WRK command actually will start, I think, 12 threads with 400 concurrent connections for 20 seconds, and simply will attack the health API that I was just there. And actually, before doing anything here, do you realize the huge problem there is here? Massive issue here. How many of you have experienced an outage based on there's no space left on your instance? It's actually an outage that happens super often. And the very important thing here, resiliency-wise, would have said, hey, there's way too much logging. Let's drop the logging, right? Because that's actually an easy way to DDoS someone, is force them to have too much logging. That will take the instance down. That's a typical way attackers do a DDoS attack. It's not by taking your concurrent connections out. It's simply to force the system to log too much, and then you run out of space on your instance. If your instance run out of space, you can't open connections because an I/O operation needs space on your drive. So here, a big problem before doing anything is actually, in a production system, I would easily run out of space. So I need to figure out how to drop that logging experience. But let's do it again, because I want to show you another way. So here, my health API. All right, let's run that again. You see the time it takes now. So imagine, whoa, it takes actually a long time. What is wrong with that? Well, there's a massive problem with actually this. This behavior is that if I'm in an auto-scaling group and my load balancer is looking for health check in the instance and can't answer, and the instance doesn't prioritize health check, well, guess what the load balancer is doing? Taking it out. And say, oh, it's unhealthy. I'm not going to send traffic, and then test others. And you're removing instance from a load balancer, so other instance will get more connections and won't be able to answer else. And that's the cascading failures. That has happened to me several times. All right, so in a situation like this, very good way would say, oh, how can I prioritize my health check and say, oh, the other API is bombarding it. So, well, a very easy way to do that is rate limiting, right? So let's do a rate limit, and we take 10 bursts per minute, right? So let's see that. We do that, and then all of a sudden, I'm rate limited. So now there's another problem. You say, of course, I'm rate limiting the same client that I'm playing with, right? But in theory, if I have a different client, then my rate limiting should work. But you see now, my rate limit actually should be a bit smarter and say, hey, actually it came from a different client. I should probably take the XIP or the client, a different hash to figure out the rate limits. So it's actually a lot of different questions that you can start questioning yourself and say, oh, how can I even locally make this more resilient? And I think that's already a lot that you can do just starting from that. So yeah, make sure you actually play by first trying to DDoS yourself before someone else does, because you will learn a lot from your application. Another very cool command that I really like is the TC on Linux. That will simply add a 200 millisecond latency on your ETH0 interface. Right? So do you know latency, the problems of latency? How many people of you play Fortnite? It's the same. Every time I use these questions, everyone laughs. No one raised their hand. It's the same. Like, how many of you are on Tinder? It's no one, but everyone plays Fortnite. I get killed in 10 seconds on Fortnite because of latency, because the kid is usually much faster than me at answering. Actually, my response is usually 500 milliseconds, 600 milliseconds. The kids I play with are usually able to kill in 300 or 400 milliseconds because they've been training a lot. And that's usually the effect of latency. If you want a tangible effect of latency, on the retail Amazon.com page, we make A/B experiment of adding 100% latency on the web page, and that's an effect of reducing the product orders by 1%. Every 100 milliseconds. It's something the human brain doesn't even realize. It just means that people that experience a bit more latency won't spend much time on your page. And the more you increase this, actually it's going exponential. Past the moment, they will just never go back and that you lose this. So we use a system of latency bucket for our page. We say our page needs to be loaded in, let's say, maximum 3 seconds from all the services, and then we cut and degrade if it's not at 3 seconds, for example. Depends on which page, of course, right? But you get the idea. So that's a very good thing to do and figuring out the effect of latency. One that I love is actually, I don't know if many of you knew the stress stress product. It's a small tool on Linux. There's an updated version of it called stress ng. That also helps you to randomly kill stuff or add CPU burn on your environment. So something like this. Oops. Oh, I'm in the wrong, sorry. Up. I'm in the wrong shell. I need to quit. Okay, I lost my shell. Clear. Okay, I lost that one. So I won't demo this one, but that's a good way also to add stress in your system. I'll show you some other way. That's actually something that you should definitely add in your tools if you want to randomly add the CPU burns to your application. Another very interesting thing to do is play with IP tables. And one of the easiest way to break your application is remove access to DNS resolvers. Right? So basically cut TCP and UDP port to 53. You drop that traffic from the IP table and see if your application depends on DNS activity or if it can cache locally, if you can use that. That's a very good way of testing, I think, local applications as well. Other fun things to do using most of the Linux tools already is fill up the disk. You can write a massive file to fill up the disk and see what's gonna happen. You can do traffic shaping to increase packet loss in your interface. You can detach all the volumes and say, oh, what happened? You don't have disk anymore to write to. What do you do? How do you behave? Do you gracefully degrade? What do you do? Or mess with the etc host as well. It's a very good way. Do you have a discovery service that you can rely on? If you detect a change of the host, can you recover from that? Does it repair it? A lot of things to do. If you want to have an integrated suite of chaos tools, there's a very good one, of course, from Netflix, the Seaman Army. The only downside of this is really integrating heavily with Spinnaker, which is a deployment pipeline tool. And that's what Netflix uses. Luckily, everything is open source, so you can still take the code out of all that and play with the army. But I found it quite complicated actually, and there's a much more easy way to do it. But it's definitely brilliant to look at the code and get a lot of ideas of what you can start breaking. My favorite is one of my favorite is the Chaos Toolkit. That's a toolkit that is API based, so it's open source. You can write code to test an experiment. Right. I'll show you how to do that. So, sorry, I'll go that. This is how you would write an experiment here. From the beginning, you start with the steady state hypothesis, right? So it's how is your application responding into a normal mode? This is just to show you how the framework with. This is working with my Docker Compose experiment. Here, you want to make sure that it answers 200 on the health check. And then you have methods to actually do the experiment. And there you see I just do a Docker and I check the PID of the master. Then I stop that. Basically, I just do through code what I did with Docker stop. And then the good thing with that is actually you can integrate into a CI/CD pipeline. Right? So here, after that, after breaking database, I do a probe on echo. I can pause after, let's say I'll do 10 seconds here. Then I read again my health, and then I restart my database, and eventually everything should go back to normal. So I'll show you in practice how this works, like, because actually that's the cool thing. So if I do into chaos, project, Eleanor, chaos, do you all see the screen? Is good? Yeah, okay. And then you can start your experiment. So experiment db down, and what it will do here, it will start running my experiment, and you can see, of course, that here is degrading the database, shutting nodes. So it's very nice way to start writing some kind of test suites, I think, or experiments, and that you can then run regularly while you deploy software. Because very often between versions deployment, you want to be able to automate and maybe find problems, right? So I think that's a beautiful way to do it, and it's very simple to use it. There's a lot of plugins for different cloud providers that you can, out of the box, start breaking things. And you see here my experiment kind of at an error, right? So you can say, all right, in this deployment, actually, my experiment failed. So then you can deep dive and say, oh, what happened? And I think it's a very good way to make sure you don't have between deployments or between versions, you don't have a drift, and you don't have, let's say, a loss of resiliency as well. So something definitely to look at, this chaos toolkit. Actually, I can show you quickly how one looks if you want to integrate for EC2. This is simply terminating randomly stuff into an availability zone. So you see I have the chaos AWS, and then I call EC2 and the probes, and then I can count instances and say, oh, here my steady state hypothesis has to start with there is some healthy instances, regardless of what they do, and then I just start breaking randomly those instances. So I stop instances in that availability zone with instances that have this tag chaos ready. Right? You don't want to necessarily break all the other instances. You want to make sure that you target the instances that are ready. So that's actually quite flexible framework, and I highly suggest that you look at it, especially if you are interested in continuous deployment and pipeline for your chaos experiments. Then there is Gremlin. Gremlin is a kind of destruction as a service, so to say. It's a company that was founded by two ex-Amazonians that were part of the resiliency team at Amazon, so they have a lot of experience. Actually, we use similar tools internally at Amazon to do chaos experiment and test our services. They've done a kind of a customer version of it. I want to demo that to you. Before demoing this, you see here I'm running an architecture which is multi-AZ. So I have two servers, two WordPress instances deployed across two availability zones, and that's basically what it is. Right? It's my WordPress stuff. I can write things. If I know how to use this, I have one post here. I can modify that. So you get the idea, right? I can start. You can update that. So basically, my application is working across multiple AZs. It's resilient. If I break one of these instances, it will recover, right? So let's test that. So to do that, Gremlin is actually very nice. What Gremlin works on, you have to install an agent in the backend. So in the instance, I've installed an agent that communicates with the service, and that offers me basically this is my agent. You see, I have two of them. I can select those, and then I can start playing experiments. And this is the kind of attacks they have. So first kind of attacks, they have resource attacks. So you can consume CPU, you can consume disk space, you can consume target I/O. So all the stuff we've talked about, you can take memory down, consume it, and say how much memory you want to take. What's the percentage of memory you want to take out from your instance? That's a very easy way to break your JVM, by the way. So make sure that if you do that, you're resilient. On the state level, you can kill processes. You can simply shut down, or my favorite one, time travel. Yeah, change the time of your instance and see how it behaves. I've never ever seen an experiment that ended well. So it's a sure thing to break it. Especially in distributed systems, if you have data replicating, it's a mess. On the network level, you can create black holes, so that means there's network never go through. You drop all the traffic. You can block DNS, the same thing that I mentioned earlier. So what I really like with Gremlin is that in kind of a nice UI, it integrates all these kind of things we talked about. The downside is you have to install an agent, and that agent kind of discuss with a third-party service. So, you have to make sure that you kind of trust that. It's also quite interesting. It's not the on-demand license, so you have to have sales discussion. I've had a discussion with sales and back and forth trying to figure out what kind of license I could have and how much I need to pay, what my consumption is, which I think is kind of outdated at the cloud age. But anyway, I think the product is pretty amazing. So let's see this in action. So we selected our two targets here, and we're gonna do a CPU attack for 60 seconds, and let's unleash those ones. And I've connected to my instances. You see they are here, and you see the CPU attacks are gonna happen. So the first one here, and then the Gremlin's actually here attacking the instance, and then I can start playing with WordPress. How is WordPress reacting to that? So it's not too bad. I want to write a post. I want to store some stuff. I say they've done quite a okay job. It's not really CPU demanding. Maybe they load a lot of stuff on the UI. So that's running. Well, the interesting thing here is if you detect a problem, you can just out everything immediately, and within second, the experiment will stop. Right, so you see now my attack will stop. So they bring all that out of the box, and I was told that they will improve their license and sell stuff because I complained to them. So, but anyway, definitely have a look at Grimian. They have a free tier, a free offer that you can just start playing with and install it. They support Docker, so you can install that on Docker as well. They do that on Kubernetes as well. It supports a lot of stuff. It actually also integrates with the previous Chaos Toolkit I showed through APIs. So you can run Gremlin through the Chaos Toolkit CI/CD experiment, which is brilliant in my opinion. So definitely have a look at it. Now a rather new one, but actually something I really, really love is Proxy. It's a proxy that is open source by Shopify, and it allows you to create kind of proxy, obviously, between your client and your dependencies. So whether it's want to talk to a database, to Redis, or to your containers, and you can inject toxics. So I want to demo that to you quickly. So here I have a Redis installed on my laptop. I can connect to Redis. So if I do a Redis, I can get foo, and yes, it's bar. You can set bar and foo. Okay, it's fine. So it works. So But that's connecting directly to Redis. What we don't want that. So what we want is connect through the Toxic proxy. So you see here, I connected a proxy for Redis on port 20,000. That will then communicate with that. So then I can then do something like this. Whoop. 20,000. And you see, I can still get my full. But now there's no toxics here, right? So let's create a toxic. So what we can do is toxic. We can add a toxic for Redis and a latency-based toxic that will add 1,000 milliseconds latency. So basically a second of latency. And now if you test that, you see up. And if you get full, it's added this 1 second latency. So it's very easy to add in your system if you have if you want a proxy request to your SQL database and see the effect of latency. Super easy to deploy. Shopify does recommend you don't run this in production. They do say they've hardened it 3 years. They've run it 3 years in their architecture. They use it very heavily, so it's ready for prime time. But they still say maybe don't do it in production at extreme large scale. But I think it's a brilliant way to start experimenting both locally here with how your system react and how your containers might react to latency. And I think it's a brilliant way to interface with the tools. If you are into Kubernetes, there is a brilliant one that is called KubeMonkeys. I won't have the time to demo that, unfortunately. Maybe next time. The KubeMonkey is actually very nice because it's almost a port of the Simian Army or the Chaos Monkey of Netflix to Kubernetes. So you can randomly kill pods, and that's also something that you definitely want to test before pushing your Kubernetes cluster in production. Another very good tool, especially if you're using Docker, is Pumbaa. So all the stuff, Docker stop, Docker start, things like this, get the PID, is actually abstracted by Pumbaa. So Pumbaa helps you to do that way more easily. Definitely have a look at this. It's a brilliant product. Integrates with a lot of tools. And then if you are into adding also latency, Tundra, which has a product for mostly to monitor and things like this, also have some possibility to do chaos tests, especially Lambda functions. And if you're using databases on AWS, we support this kind of testing failovers, and also we support query injection, fault injection directly on the database. That's for Aurora. It's our SQL database that is Postgres and MySQL compatible. And you can simply run commands like this. There's few of them you can run, and there's a list here. This is the command to add a percentage of these failures in your database and see how your application is going to behave. Finally, if you are into Lambda and serverless, I wrote a chaos library using Lambda layers so that you can inject latency either in the Lambda function itself or through methods and decorators in Python that you can put on top of your function and add latency so that you can see how your code behaves at scale. There's a whole blog post written on that. It's also on my GitHub account, together with all the code and the stuff I deployed today, so you can see how bad I write code and how much work there is to do on resiliency. I want to finish on some of the challenges with chaos engineering, because if you start a practice of chaos engineering, you will have challenges. As I say, Eleanor is my baby. Well, most code developers will behave like that. That means that if you criticize or find faults in their codes, they will usually take it very personally. Which is stupid, because the whole point of writing code is actually to improve it and make it resilient, and there's no one way of doing it. Usually it's great, but naturally people that write code, including myself, always have this fear of being criticized. So in the early days of chaos engineering practices, make sure that you kind of take a soft approach to pointing out problems. Never ever blame anyone. Blameless cultures are very, very important. And it also is not going to replace normal testing. This is super important to point out. A lot. I've seen folks focusing on chaos engineering, and then they don't necessarily support functional testing, all this kind of stuff. It doesn't mean you have to have 100% coverage. This 100%, but I think it's tools and things that definitely test and try different things. And your system will actually continue failing because that's just what it is. So the problems are mostly cultural. As I say, it will often highlight a choice of a bad framework, or Python versus Ruby, or C++ versus C#, or Java versus the rest of the world. It's often like that. But at the end of the day, if you are patient and if you work through culture, it actually makes sure that you don't blame people. And that's what I want to finish on. I wouldn't be here myself if I wouldn't have a blameless culture before joining AWS. Actually, I cleaned database in production once, a few times. Cleaning means deleting. And my manager never ever blamed me. He must say, how did this happen? That we could run comments for deleting database in production, and how can we prevent that? And then we went into building sets of tools to actually prevent doing these kind of things. And this is how I started with chaos engineering and building tools, things around preventing problems versus blaming the people doing those stuff. Because one day or another, you're going to do the mistake anyway. So don't do it. Thank you so much for your time. Hopefully that inspired you to start or look a bit further with chaos engineering. You can directly download these presentations with all the links on that one. It's already uploaded there. I should definitely have done a QR code, but then your phone would have been overloaded with a presentation. And I'll push that on my Twitter account as well, @horn, that link, so that you can also use that on Twitter. And don't hesitate to contact me. I'm happy to discuss about chaos, resiliency, and all that stuff. That's what I do for a living. So thank you again.